Hi everybody, this is Mr. Ege and I'm going to show you a few interesting things about the paper, about the strength of materials, and this is more particularly, this class is going to be about the strength of a paper. And paper is an interesting material. This is a construction paper which is 9 inches by 12 inches. It's very close to NC, A size paper. And you can see it's not strong enough even to carry its own, to support its own weight. It bends right away. It doesn't stay like that. However, if I turn it around like this, and I hold it like that, and you can see exactly its strength has changed. It's supporting its own weight, even maybe more. Okay, so what happened? What is the difference between this? It doesn't even support its own weight. And when I turn it around, and it's now stronger, seems to be stronger. The scientific engineering answer to this question is the moment of inertia changed. There is a particular formula, okay, for the sections, rectangular sections. And that particular formula is 1 over 12 BH cubed, directly affects the strength of the paper or any other material, okay? This has been known since Sir Isaac Newton times. It's very interesting. He enabled, by just discovering calculus and developing the calculus, Sir Isaac Newton enabled us to calculate any strength of any kind of shapes, because you can calculate the moment of inertia of different shapes. Now, what can you do to make it stronger? Because it's not holding, other than just turning around. Probably you can, one of the things you can do, you can just fold it like this. This also changed. When you fold it like that, the paper, it also changes its moment of inertia and it becomes stronger that way. However, today we're going to focus on paper columns and paper columns of different shapes. And we're going to see how it's going to be affecting our paper columns. So I'm suggesting you do this experiment and take me a picture of the experiment and email me to aeege@fcpsschools.net, okay? You need a paper, at least three papers, construction. NCA size papers are fine, that's 8.5 by 11 inches. This is a construction paper, it's a little bit bigger than NCA, 9 inches by 12 inches, but doesn't make huge difference. At the end, we're going to learn something even from a paper. So, what I'm suggesting you to do, all right, take the paper, hold it like horizontally, like this one, okay? And we're going to, and then you need to cut a tape, okay, 9 inches long tape, okay? And we're going to tape one end of it to the other end, okay, like this. And then we're going to just fold it this way and tape it as perfect as we can, okay? Like that, okay? Now I have a circular column. All right, I'm going to put this aside. I want to create a triangular column. And the triangle is 3 folds, so I'm going to take another paper, it's a black paper, I'm going to just fold it like that into 3. Let me show you how I did that. Just like I'm folding just like a letter into 3, okay? So it is 3 folded, so it's going to be a perfect equilateral triangle section, okay? So you need another 9 inches long tape. And that tape needs to be attached to the one's edge halfway, sticking out halfway, okay, like that. And now the other edge has to be connected to it, okay. And well, if you think this is a lot of work, yes, you are right. Engineering is a lot of work. And you have to test so many tests every time. You cannot rely on one number, one formula. You need to test things. So now we created a triangular column. I'm going to put this aside. And now I'm going to create a column of a rectangle, probably more like a square. Okay? And I'm going to divide it, fold it into two. I'm going to fold again another two so that I can have four sides. And it's critical to have four equal sides to make a perfectly square column. All right, as you can see. And now I'm going to use another tape like that. Okay. Okay. Carefully joining the edges. Okay. And now I have not so perfect, but it's a square column, as you can see. That. So I'm going to test those, okay, column for the weightlifting. I have also a scale, bathroom, kitchen scale, okay. Bathroom scale will do maybe, but kitchen scale is perhaps better because those paper columns are not going to lift too much weight. I'm taking this triangular column right now, okay, over here. Perhaps you can see it here. Right, and like this. And I'm going to test, put some weight on it. This book, The Southwest Gene, very famous traditional book, Dr. Richard Dawkins. It weighs exactly 406 grams or 0.406 kilograms. So, and you're going to put this on top. Okay, so it's almost failing. Let me see. 406 grams. And I want to just see. There it is. And it carries this, it supports this load. I can put another load on top. And I could, before it falls down, maybe I can put another little bit more, one more magazine. And we're going to see this. And it's going well. Okay, so it didn't take the last magazine. And I'm going to weigh all of these. And I want you to do that. Weigh it, okay? And let's take the square column, okay? And the square column, I'm going to load it a similar way, okay? I'm going to put this weight on top, okay? I'm going to put these additional weight that the triangular column collapsed. Another weight. Okay, so this is the square column, the strength of the square column, this much book. Okay, and I'm going to finally test the circular column, cylindrical column. Okay, all right, we're gonna put this famous Richard Dawkins book, Southwest Gene. I recommend everybody if you're interested in DNA. Okay, and we're gonna put a little bit more weight, a little bit more weight, a little bit more weight, and so on. It goes on and on until it, okay, collapses. And I want you to weigh everything. I want you to weigh every time books, and then compare those weights. Okay. So there is a PowerPoint presentation with the questions attached to it, and I want you to take that test. There's some calculations, moment of inertia calculations, that these are the basic engineering calculations. It introduces you the concept of moment of inertia. Moment of inertia is basically an effective, efficient cross-sectional area of any design. And it changes. Even though material is exactly the same, it changes even from design to design. And design is in the hands of engineers. So you can make an object without increasing the size or weight of the object, materials of the object, by just changing the design, and you can make it much stronger or much weaker. Okay, and that's the lesson to learn from this activity. I would like you to take the picture of your activity and email it to me, please. And I'm going to grade it. And there is going to be 4 grades I will be explaining to you. And have a great day. Thank you for watching.